Hey 8th graders, it is Miss Miller. We're going to review scientific notation today. I know lots of us are bosses at this, but there's a couple problems on the benchmark that are really easy, and we've got to be masters and complete pros at going from scientific notation to standard form and back and forth. Before we get started, I have two shout-outs. My first shout-out is going to Caitlin Jones for working really hard yesterday. She was running by herself and ran almost the entire time and really pushed herself. The second shout-out is going to Tiara Tilly. I really enjoyed running with you yesterday. I'm glad that you pushed yourself. I know that your legs started to hurt. Mine did too, but we got through it, and I'm really proud of you. All right, let's jump right into it. Here's our first problem. We'd like to write 20,360,000 in scientific notation. So I know that if I'm writing in scientific notation that my number needs to fall between 1 and 9. So I'm trying to decide where would I put my decimal point so that I land between 1 and 9. Well, I know that my decimal point would go really well right between the 2 and the 0. So I'm going to rewrite my number down here. It's going to be 2 and 36 hundredths. And I don't need to include these zeros because that doesn't change the value, but I do need to include both the 3 and the 6. So I have 2.036. That is a number that falls between 1 and 9. Now I have to see times 10 to what power will this be? Well, let me see. How many times do I move the decimal point from where I placed it, which is right here, to all the way over here? Let's see. 1, 2, 3, 4, 5, 6, 7. I moved the place value 7 times, so this is times 10 to the 7th. The last thing I want to do real quick before I know and determine that this is my answer, I want to see, was my original number 20,360,000? Was that originally a really big number or a really small number? Well, it's a really big number, so I do know that my exponent right here is going to be a positive 7. I do want it to be positive. Perfect. All right, we are going to take that. We'll take this. Oops, hold on. All right, now that we have that one done, we're going to move this over, and we're going to solve another problem. So this time I'm going to deal with a number that looks like this. And this is a decimal point right here. Copy this into your notes as I write it down. I want to take this number and I want to write it in scientific notation. Now I know that if I'm writing in scientific notation that my number needs to fall between 1 and 9. So let me see where I could put my decimal point. Well, right here would be a really great spot between the 6 and the 5 because 6.5 something is in between 1 and 9. So I'm going to go ahead and write that, 6.5. I need to include this 0 because there's another digit that's not a 0 after it. So 0 and 1. I have all of my numbers. Now I want to see times 10 to what power will this be? Well, how many times do I have to move my decimal point from here to here? My original spot on my decimal point to where I decided that it's going to be when I'm writing in scientific notation. How many place values is that? 1, 2, 3, 4, 5 place values. So I know this is going to be 10 to the 5th power. And again, the last thing I want to do before I check, my original number, I'm going to rewrite it down here, was 0.0006501. I want to take a look at this number. Is this number really small or really big? Well, this number right here is really small, so I know that my exponent's not to the 5th power, but to the negative 5th power, because anytime I'm raising to a negative, I'm dividing, which makes my number smaller. So here is my final answer. Awesome. All right, I'm going to take this and move it up with the other problem that we did. And let's try another one. Sometimes we're going to get problems like this. I have the number 486,532. 486,532. And I want to write this in scientific notation. Now, there are no zeros, but I still can take a number like this and write it in scientific notation. I want to figure out first where would the decimal point go. I want it to be between 1 and 9, so it's going to go right here between my 4 and my 8. So I'm going to go ahead and write that. I now have 4.86532. I need to include all the digits that follow the decimal point. And I want to say what that's going to be times 10 to what power. Now I need to see how many times will I move the decimal point. 1, 2, 3, 4, 5, I moved it 5 place values, so this is times 10 to the 5th. Last thing I want to check, was my original number really big or really small? Well, my original number was 486,000, which is a pretty large number. So is this going to be a positive 5 or a negative 5? It's going to stay a positive 5 because my number is really big. Cool. This is my answer in scientific notation. Cool. This is also going to go up with the rest of the work that has been done. And let's do another problem. Let's make it go right here. All right. So we did a problem where there were no zeros and it was a really big number. We're going to do something similar. I have 0.2349. That's 2,349 10,000ths, and I want you to write that in scientific notation. So first I need to figure out where's my decimal point going to go. Well, I want to know it wants to be between 1 and 9, so it's going to go right between my 2 and my 3. So I'm going to go ahead and write this number 2.349, and I'm going to multiply that by 10 to some power. Now, I want to see how many times did I move the decimal point, and this is where it gets a little tricky. From this spot to this spot, how far from where it originally was to where I said it needs to be in order for it to be between 1 and 9. Well, let's see, how many place values is that? 1. That is only 1 place value. That's all I moved it. So if we see a problem like this that's trying to trick us, use what you know. You know it's between the 2 and the 3. Then see how many times you have to move it. That was just 1 time. Now I need to ask myself, was this a big number or a small number? Well, this number had a decimal point right here. So I know there was a small number, so it's times 10 to the negative first power, because anything that's a negative exponent means a smaller number. All right, now we're going to take numbers that are already in scientific notation, and we are going to put them into standard form. So here's my first number, 2.682, and we're going to take this times 10 to the 7th power. This is written in scientific notation, and I want to put it in standard form. What standard form tells me to do, I can first look at my exponent. It's 10 to the 7th power. That doesn't mean that I'm going to have 7 zeros, but what it does mean is that I'm going to move my decimal point 7 times, and thus change the place value 7 times. So I'm going to go ahead and rewrite this number. This was 2.682. I'm moving the decimal point, or the place value, 7 times. So 1, 2, 3, 4, 5, 6, 7. I can fill in these blank spots with zeros. And I knew I was moving to the right because my exponent is positive, and a positive exponent results in a larger number. So I'll move this up a little bit. Let's write our final answer. Our answer is 2682, and we should have 1, 2, 3, 4 zeros. I can add in my commas, 26,820,000. Awesome. All right, last one I want to do is kind of a tricky one, so stay with me. Let's find a new blank spot to do it. We probably haven't done one like this before, but I think that we'll be able to figure it out. So I have the number 8.653214. Ooh, that's a long one. Make sure you got it. And we're going to multiply this by 10 to the 3rd. This is written right now in scientific notation, and I would like it to be in standard form. So first thing I want to do is look at my base and my exponents. Sorry about the dog barking. He might show up a few more times. Bruce likes to bark sometimes. So first thing I was doing was looking at my exponent. My exponent is 3, which means I'm going to move my decimal point 3 times. That does not mean I'm going to have 3 zeros, but just that I changed the place value 3 times. Well, is this a positive 3 or a negative 3? It is a positive 3, so I know that my number is going to get bigger. So let's go ahead and take this number. I'm going to rewrite it down here. 653,214. And there's my decimal point. I'm going to move it 3 times to the right because I'm going to make it larger. 1, 2, 3. Oh, that's super goofy. It's still a decimal point right in between numbers, but that is totally fine. So this is 8,653.214, or 214 thousandths. This is my final answer, written in standard form. You guys have the rest of your packet to do. front and back side, and when you are finished, go ahead and bring it up. Good work today.